Welcome, everybody, to the weekly air quality discussion. My name is Jeff Beamish, air quality meteorologist at Sonoma Technology in the San Francisco Bay Area.
And I am Patrick Zahn, the lead air quality forecaster for Sonoma Technology.
And I'm Steve Irwin, air quality forecaster with Sonoma Technology.
This week's air quality discussion is brought to you by one word: smoke, and a lot of it is covering the United States at this time. What you're taking a look at here is the MODIS Terra satellite image from yesterday. Look at all of this milky imagery that you're seeing right here. This is all wildfire smoke from the upper Midwest down to the southern plains, stretching into the Ohio Valley and the northeastern portion of the United States, including the mid-Atlantic. So now the big question is, where did this smoke come from and what's the history behind this air mass? We're going to talk more about that. We're also going to talk about the historical perspective, just how bad is the air quality versus years past. And we'll also take a peek at the upcoming weekend and next week, where the smoke may be heading and other weather patterns that we're going to be tracking that'll impact air quality. For now, though, I'm going to toss it over to Patrick to talk a little bit more about where all of this smoke is coming from that is covering the United States.
Thanks, Jeff. So what we're looking at here is a map of the HMS smoke plumes and fire detection. HMS is the hazard mapping system. These smoke fire detections come from satellites. So the satellites are looking straight down at the ground and they can pick up where the smoke and fires are. Each little red triangle here represents a hot spot or a fire. You can basically throw a dart at a map of the US and Canada, and right now you will hit a region covered by smoke. So I also want to show yesterday's PM 2.5 levels. We're going to drill down into more detail in a second, but these are the 24-hour averages with the yellow, orange, red, and purple colors representing progressively worse PM concentrations. Much of the country covered by moderate or worse air quality. You can see pockets of unhealthy for sensitive groups over in the eastern US, and regions with unhealthy or very unhealthy AQI levels in the upper Midwest and stretching into Canada. So I want to take a minute to talk about the large-scale weather patterns that are contributing to both the smoke accumulation and the smoke transport from numerous fires in the Pacific Northwest, Western Canada, Central Canada, and throughout the US. Also, you can't really see it here, it's obscured, but areas of Oregon and the Sierra Nevada in California. So I'm going to switch over now to windy, and what I am showing here is the 300 millibar wind pattern for today. Strong upper level ridge that's pushing the jet stream way up into Canada and then coming right back down into the northeastern US. Under an upper level ridge, you have limited vertical mixing. That means that any air that you sort of perturb vertically upward in the atmosphere will just sink back down. So it contributes to sinking air. And when you have a situation like that, when there's a lot of smoke buildup near the surface, it's not going to get mixed out away from the surface. It's going to be trapped near the surface, and it will lead to poor air quality at all of those observation sites that we saw. So this wind pattern is not unique to the upper levels. I'm looking at 300 millibars here, which is maybe 30,000 feet above the surface. But if you go down into the lower atmosphere, you can also see a similar pattern here in the lower atmosphere where there's transport from areas here. This is Manitoba and Western Ontario, southward into the eastern US, and we're going to be focusing on that a little bit more. But I wanted to point out that that transport pattern was consistent throughout that atmospheric column, both at upper levels and near the surface. Now I'm going to hand it over to Steve Irwin, who's going to talk about the progression of this weather pattern over the last several days and how that has contributed to smoke accumulation and transport.
Thanks, Patrick. Yeah, looking back, so this is a map of air quality and smoke and fires going back to a week and a half ago. So this would be last Monday, July 11th. And if we look at the country, we can see smoke was already covering much of it, except for over the east, but much of the west and across Canada, the sky was filled with smoke. And so these fires are very far away from a lot of locations that are being impacted by the smoke currently in the central US, the southern US, across the mid-Atlantic. So one thing we look at as air quality forecasters is how do we get the smoke from aloft down to the surface? Because a lot of times these fires will be producing a lot of smoke right in the vicinity, but these fires are huge and they're burning very hot. And so a lot of the smoke and ash is going straight up really high into the atmosphere. In previous summers, if we think back over the last 5 to 10 summers, this is not an unusual picture. In the summer in the US, we see this expansive area of smoke, and folks are used to seeing the pretty sunsets that come with that, but they're not used to seeing the smoke come down to the surface over such a large portion of the country. So I went back and looked at kind of how this air mass originated and what made this episode so bad. And so keep in mind this graphic where the fires are, a lot across Idaho, Northern California, into British Columbia, and then all the way eastward into Western Ontario. So if we pull up the weather map from a week ago, this shows fronts, high pressure systems with the H's here and low pressure systems with L's. But as we look at this map, what you can notice over the region where there were a lot of fires occurring a week and a half ago and still are, there was a high pressure system. And so if we kind of move forward in time here, this is just each 24 hours, a snapshot at 7 a.m. each day, how this high pressure moved. And so it came from where the fires were in British Columbia, and it came across into the northern plains, into Minnesota. That was by Thursday of last week, July 15th. And then it's following behind this cold front here that's moving through the Great Lakes on Friday. This low pressure stalls it out a bit, but then on Sunday it really makes a big push into the Ohio Valley and toward the eastern seaboard. And that's really when we started to see the smoke concentrations ramping up in places like central and eastern Ohio, and then also out into Pennsylvania. And so what high pressure does, why we watch that a lot for air quality forecasting, is it will keep the mixing very minimal down toward the surface, but it also has the power to bring smoke from higher levels down toward the surface. So all that smoke that was bottled up as it moved from the fires over British Columbia to the fires over Western Ontario, that all came with this high pressure system into the Great Lakes. And then as we play it forward to just yesterday, should be July 20th, you can see the axis of this high pressure. So the middle of it comes right from where those fires are down through central Minnesota, central plains, into the Ohio Valley, and up to the eastern seaboard, where they have been experiencing the worst air quality from this episode. And I really love this graphic, Jeff, that you put together that shows some trajectories. This is the high split model that just shows us where has this air come from? Where did it originate? And it really shows the story of that high pressure system moving from British Columbia all the way into the Ohio Valley. And all that smoke that was sitting there a week and a half ago is now affecting a large portion of the country, not just with pretty sunsets, but with poor air quality.
Steve, I just wanted to mention that these trajectory lines, the red, blue, and green lines, those are showing trajectories that end in the U.S., so parts of the Midwest stretching into the Mid-Atlantic. So what those lines are showing as they stretch back into Canada are the source regions of those air masses that end in the eastern U.S. And it's really highlighting, as you said, the transport path of smoke from those areas that have the densest fire detections right into parts of the eastern U.S.
Yeah, it really paints a nice picture, Patrick, of where it came from. And it originates almost from the center of both of those huge complexes that are ongoing across southern Canada. So yeah, this is a great graphic, Jeff.
Thanks, Steve. Yeah, now taking a look at some of the concentration values that were observed from regulatory air quality monitors across the country yesterday. So this would be Tuesday, July 20th. And you can see some very high values. The orange indicating monitoring sites that finished the day with unhealthy for sensitive groups AQI values, and the red like for instance, just south of Youngstown, Warren, and in and around New York, New Jersey, that indicates unhealthy air quality due to this smoke. Another thing I want to show really quick as we click on the Modus Aqua satellite image is how this smoke was sort of sandwiched between two frontal boundaries. There's one frontal boundary that was across the Great Lakes yesterday, just north of Detroit, Columbus, Youngstown, another frontal boundary south of New York, New Jersey, the tri state area down toward the mid Atlantic. And between these two weather systems, that's where that very dense smoke from wildfires was settling in, causing very high AQI values to be recorded. So, how about some historical perspective now regarding the air quality that was recorded on Tuesday, July 20th? So, I pulled up a couple of different spots across the country. This is from the EPA Air Data website. This is a database we can go into to take a look at daily AQI values going all the way back to 1999. So yesterday in Youngstown, Warren, unhealthy for sensitive groups AQI values, you can see that with this orange, I call them chiclets because they're different colored tiles that indicates what the daily air quality is. And you can see the AQI category scale down here. Nonetheless, yesterday, July 20th in Youngstown, unhealthy for sensitive groups AQI values. And just during the summer months, if it's not the 4th of July in Youngstown, Warren, generally their AQI values or PM 2.5 are either good or moderate. The last time that they had an unhealthy for sensitive groups AQI day that was not related in the summer months to the 4th of July, you have to go all the way back to 2011. So let's take a look at a couple of other different cities. For example, Newcastle County, Delaware, the county seat there being Wilmington, just to the southwest of Philadelphia. They too had an unhealthy for sensitive groups AQI day due to the smoke on Tuesday, July 20th. And again, you go back into the database here for EPA, and you can see during the summer months, generally very clean air quality due to PM 2.5. And their last summer exceedance that was recorded in the Wilmington area, you have to go back to 2011. Finally, let's talk about the tri-state, New York, New Jersey. Unhealthy AQI values yesterday into the New York, New Jersey metropolitan area. And you have to go all the way back, and I mean all the way back into the summer months to what, 2011? Again, for another day for an unhealthy for sensitive groups AQI reading. So we're talking about some air quality readings that have not been seen in quite some time, or in some places not recorded ever, going back to 1999. And to that point, as I go back to Air Tech Navigator, and I want to point out yesterday, July 20th, what was happening up in northern Minnesota. Steve, I want to bring you in here because some of these daily AQI values around Leech Lake and Red Lake, I mean, these are incredibly high concentrations due to smoke. Let's talk a little bit more about that because you do have a lot of experience from your days working at the Minnesota Pollution Control Agency.
That's right, Jeff. And I can't remember seeing concentrations this high. If they were, they would have been for 1 hour averages. These were 24-hour averages from yesterday in north central Minnesota. Just incredible to see very unhealthy air. They do see a lot of wildfires north of the border and even up in northeastern Minnesota. That happens each summer. But what's different about this one is the duration of the episode. So what we used to see is you would get these quick bursts of smoke that would come in behind cold fronts, kind of like we've been talking about, but they would be short-lived. They would last for several hours and then they would move through. They have had to issue air quality alerts for smoke on and off since, I was just looking back through my notes here, and it looks like the first air quality alert was issued around July 4th, not related to the fireworks, but related to smoke. And so they've been dealing with this almost all month long up in northern Minnesota. And you can also see getting down into central Minnesota and into the Twin Cities at times as well. So definitely a historic event happening in Minnesota this July.
So one thing I wanted to mention here was we've been focusing on PM 2.5, both in the current situation and the historical context that Jeff was providing. But the smoke also appears to be impacting ozone. So smoke can lead to both high particles and it can enhance ground level ozone formation, which is what we're seeing right now from the DC area stretching up towards Philadelphia and over much of Delaware in between. So we're seeing unusually high ozone levels, and we think that those levels have been boosted by the smoke. Normally, under the current situation, I think there's west-northwesterly winds at about 10 miles an hour. Normally, we'd expect those winds to disperse pollutants and lead to lower ozone. Right now, they're just transporting that dense smoke into the region, leading to high particle and ozone levels. One caveat, if the smoke gets too dense, it will actually block sunlight and lead to lower ozone. Looks like we're not quite at that situation right now, but we're seeing both high PM and high ozone.
I'm glad you mentioned that, Patrick, just about kind of the photochemical reaction that can happen when there is too much smoke in relation to ozone development. And I go back to August of last year here in the San Francisco Bay Area when we had very thick plumes of smoke over Northern California that really shunted the sunlight and really shunted ozone development altogether. In fact, it was very odd to see back then when we had very high AQI values due to PM 2.5 wildfire smoke, but AQI values for ozone were good. So we've talked a lot about where the smoke came from. Now let's see where the smoke is heading and how it's going to play into the forecast heading into the upcoming weekend here. We're taking a look at the surface weather map, and the dominant weather feature we'll be watching, surface high pressure. Friday morning, it is over the central to southeastern portion of Ohio. By Friday night, it's into western New York and Pennsylvania. And then heading into Saturday and Sunday, surface high pressure generally moves off to the east and a warm front passes through a good chunk of the Ohio Valley and portions of the mid-Atlantic. What that pattern is going to do is shift winds around and potentially recirculate some of this smoke that is situated from the mid-Atlantic and down to the south, recirculate it back up to the north and then toward the east and northeast. So this is the Noaa air quality forecast guidance I'm showing you. This is for later today, July 21st. Here's tomorrow, generally a clean out for PM 2.5 for a lot of the region here. Watch what happens with this plume, though, in the Midwest by Friday. Starts to move a little more to the east, and we do expect AQI values in relation to PM 2.5 to start ticking up, probably not to the extent that we saw on Tuesday, the 20th, but still we could be looking at moderate AQI values for a large chunk of this area. And then Patrick, heading into early next week, another weather pattern that we're watching and how that could play into air quality. Why don't you go ahead and talk about that?
Thanks, Jeff. So looking back at the upper level weather pattern, again, I'm looking at 300 millibar winds. This is highlighting the jet stream and upper level ridge centered over the entire U.S. really, except for the eastern portion. I'm going to step through a few days and see what happens to that ridge. And it starts to flatten out a bit, meaning that ridge will weaken. So there might be a little bit more mixing in the atmosphere. But also it's showing this transport pattern from those fires in Canada still into the eastern US. So there might be additional smoke transport, at least at the upper levels. And as I step even farther forward, that ridge rebuilds. And as we get into early next week, Tuesday and Wednesday, now we've got a really strong ridge building over the western US and western Canada. That, aside from leading to really warm temperatures, that could also impact the smoke transport pattern and the accumulation near the surface. So this is definitely a situation that we will have our eye on, but again, this is looking ahead a week. So as the situation evolves, we will be tracking the smoke accumulation, transport, and the impact on surface air quality throughout the US and Canada.
Suffice to say, the smoke, at least in some degree, will still be around heading into next week for much of the country, right?
That's right.
Well, thanks for listening and watching the weekly air quality discussion here on the High Pressure Podcast. To find out more about the amazing work we do here at Sonoma Technology, head on over to www.sonomatech.com. Of course, you can follow the podcast on Twitter. We're at High Pressure Pod, including a podcast that we did while at the American Meteorological Society conference back in January 2020. We sat down with AMS on the air. We have a link for that over on our Twitter handle at High Pressure Pod. I'm Jeff Beamish.
And I'm Patrick Zahn.
And I'm Steve Irwin.
Thanks for listening to the High Pressure Podcast and the weekly air quality discussion.